Okay, so we're going to start the chapter 8, benefit and cost analysis. So you can interrupt me if you want to ask me anything during the session, but I think it's quite direct. Hopefully we can go through. So what are the learning outcomes? I mean, by the end of the session, you should be able to do all of these 6 learning outcomes that have been listed here. Basically, you should be able to explain the difference in public and private sector projects. So interestingly, before we start the class, I've been talking to Mr. Kesavan just now. So why he choose this subject? He says something on the analysis, the projects, government projects, and things and so on. And fortunately, we are going to cover that here in this chapter. Okay. And then we are going to calculate BC ratio for single project. BC is benefit cost. Actually, we are going to see which one is more dominant. Is it benefit or cost? Okay, for the project. So if the benefit is better, then we are going to choose that projects. Single project, so they have different methods. If you have single projects, we are going to calculate using the BC ratio. And then if you have more alternatives, okay, 2 alternatives using BC method, select best of multiple alternatives. You have several alternatives to be chosen. And the last one is to use the cost effectiveness analysis, CEA. Okay, CEA. To evaluate the service sector projects, and the 6, we are going to conclude the session about ethical compromises about the public sector projects. So we're going to start with this, the difference between public and also the private. So previously, if you notice in the fundamental chapters, okay, the first 3 or 4 chapters, basically you are going to assess, okay, based on the profit and loss. If you have alternatives, did you still remember what are the alternatives that you have compared between buying this machine or the machine A or machine B, by taking loan A or loan B? So it's basically they have their profit based consideration, because most of the things that you already, or that have been covered by previous lecturers, is on the more to the private things. Okay, so it is clear cut. We got profit or not? You're going to lose or you're going to get profit? You're going to make money or you're going to lose your money? So we are going to decide based on that. But here, the BC analysis or BC ratio, we are going to assess the government projects. So basically, when the government, they introduce projects or they involve in doing certain projects, like to improve the infrastructure, to have a good roads, public transport. So basically, it's not based on profit. They are not, should not doing it by profit. I mean, ethically, because it's like a contribution to the people. So how to assess is not based on profit. So we're going to see the size of investment. Usually, if it's by public, it's large. Okay, and private, they have all range of small, medium, and large. And usually the life of the project is longer, okay, 30 to 50 years. Okay, and usually for the private ones, the life is shorter. Okay, like if you say you want to buy a machine for the company, so maybe you estimate the machine can be used for maybe 20 years, 15 years, 10 years. Sometimes you need to update. But for the public projects, people are going to get angry if they can't use certain infrastructure for a significant life. Okay, so annual cash flow, no profit. But the private one, they are profit driven, as I explained before. So how usually the funding been given? Okay, based on taxes, fees, bonds, and etc. So private, they have some similar fundings. They have stocks, bonds, loan, and etc. And for the government project, usually the interest rate are lower. Okay, because they are not doing it for profit, and for the private usually is higher compared to the public. And selection criteria, they have multiple criteria. Okay, and private is primarily ROR. Since you missed this chapter, ROR is written on investment or rate of return. Okay, so you basically based on did you get back what you invest and did you get more. Okay, that would be the comparison, the profit. But for selection criteria for public, it's not only ROR, but they may have the other aspects, and of course including politically inclined. Okay, so why if it's closer to the election time, so we are going to see many offers from the governing bodies, the governing parties, you know, promising this and that. So of course they have different views, but it's also considered as the criteria. They need the people's vote, and the private is economic based on this. So we have two types of contracts here. Okay, two types of contract. One is contractors does not share the project risk. Means that the contractor who involved in building or in supplying some services, certain services, they does not share the project risk. So usually the cost that involved is fixed price and also the cost reimbursable as negotiated. We also have contractor who shares in project risk. Okay, usually we call it public-private partnership, such as design-build projects. So contractor responsible from design stage to operation stage. We have one PPP projects in UTM, which is the hostel, the College Kediaman Satria, that we have 5 blocks that can accommodate 5,000 people, 5,000 students at one time. It was built using this PPP. Means that UTM didn't pay anything, but of course, at the start, the company or the contractor or the concession, we call it concession, the people, the contractor, they build, the design, they build, and also they operate. Okay, and then UTM is like renting from them and paying a very, very high price, very expensive every month, and they're going to pay for 25 years. After 25 years, the company who built this project, after 25 years, they are going to handle it to UTM in a very good quality, and then from that time it's being UTM's. Okay, so they have some agreement and things, but that's the example of public-private partnership. So they design, they build, they operate. So they have their staffs here, okay, doing the maintenance and then the finance the projects. Okay. So what we should do, we should identify the cash flow classification and also the BC relationships, the relation. So going to this is the most important concept here. It's not difficult. So you need to understand BC ratio, right? So we should have benefits. Okay. You should have benefits. Actually, what is benefit is the advantages to the public. Okay, the advantages to the public from that project. You also should be able to identify the disbenefits. Okay, what is disbenefit? Is disadvantages to the public, and cost. Okay, cost means the expenditures by the government. And we have note here, savings to government are subtracted from cost. So we need to remember this as well. Let's say the cost for the government to build a project is 1 million. Okay, 1 million. So the cost would be 1 million, right? But when they are implementing or executing that project, they can save certain amount of money. Let's say 500,000 ringgit. So that 5,000 ringgit, okay, we need to subtract with the 1 million when we want to calculate. So that's what they meant here. If any savings to the government, need to subtract it from the cost. So basically, these are the formula that you need to understand. We have conventional BC ratio. I don't know why they call it conventional. Basically, this is the basic. Okay, is benefit minus this benefit, and the answer we are going to divide with the cost. But nowadays they say they have modified BC ratio, especially when you have more detail. Okay, you have more detail on the information in terms of monetary. We are going to see the examples. Okay, but it's basically benefit minus this benefit, and then you will minus the cost, and then divided with the initial investment. We also have profitability index. Okay, net cash flow diagram. Sorry, net cash flow, the amount divided by the initial investment. And things to be given focus. All terms must be expressed in same units. So you need to be consistent. Okay, when we are comparing, it should be present worth, annual worth, or future worth. But you can't mix. You can't have the benefit using the present worth, and then this benefit using annual worth, or the cost using future worth. No. It should be same. If you are using annual worth, so it should be annual worth for all the elements, all the terms, and for all the cases until to the end. And do not use minus sign ahead of cost. So this is the main concept. So when we calculate, okay, so we have the BC and then we got the ratio. So this is how we justify that. Okay, so this is the decision guidelines for BC. What is BC just now? Benefit cost. Okay, benefit cost ratio, and PI is profitability index. So if BC is larger or equal to 1, the project is economically justified at discount rate applied, at the interest rate given. Okay, means that when it's economically justified, usually we are going to accept, or we are going to choose that project. If it is less than 1, project is not economically acceptable. And we can clearly see the reason behind it. Why? What they meant if BC larger than 1? Anyone?
Doctor?
Yes.
The mean is benefit is more than cost.
Yes, exactly. Thank you, Mr. Kesavan. So means that B here, because we compare B with C. So if larger than 1 means that B is greater. So benefit is greater than cost. So they are going to accept because the benefit is greater than cost. But if here is less than 1 means that the cost is greater than benefit. So why it's not being accepted? And the same concept applies for the PI as well, the profitability index analysis. So the project is economically justified at discount rate if the profitability index is 1 or greater than 1, and it's not economically acceptable if it's less than 1. So that's the concept. Okay, that's how we decide based on the answer that we are going to get after we calculate. Okay, Okay, we have more. Okay. So as I told before, different nature of the problem will have a different approach. Okay. So this one is for single project. Single project means you have one, and then we are going to decide whether you want to take the offer or not. Okay. So usually this is the formula that's going to be used, either conventional or modified, as we discussed before. Okay. Here is maintenance and operation cost. So you have more additional information. Say you're going to use this. If they don't give you information on maintenance and operation, they just give you benefit, this benefit and cost, then we are going to just simply use this. Okay. And for profitability index, so present worth. Okay. Present worth of the net cash flow based on the time given and also with the initial investment. So basically, we are going to accept if it's greater than 1 for both cases. So let's see one simple example. Okay. So flood control project will have a first cost of, okay, so first cost of 1.4 million. So what is this? Cost, right?
Yeah.
It's a cost. With annual maintenance cost. So the another cost here, which is maintenance cost. Annual. So it's AW. First cost is P. Okay. And what else? The information being given. 10 years.
Yeah.
So N is 10. Okay. So this is cost. This is cost. AW, N is 10, and then they have more explanation. Reduced flood damage is expected to amount 175,000 per year. So what we can understand from reduced flood damage?
I mean, like a benefit.
This kind of benefit because they reduce the flood that usually happen. Okay, so as expected amount 175. So maybe this is benefit. And lost income to farmers is estimated to be 25,000 per year. So this is the lost income to the farmer. So it's this benefit if it's happen, right? If the so reduced flood means that they still have flood happening, right? At the interest rate of 6%. So this is I. So should the project be undertaken? So what we should do, we take out the information. So 175,000 here is benefit. Okay, it's benefit as we have identified here, right? Same thing. And then this benefit 25,000. 25,000 per year. Okay, and then cost. We have how many types of cost here? We have two. Right? First cost that we say is P. Why is P? Are you understand this? I hope you get this. Because first cost is the first time occurring cost. It's present worth. Okay.
P0.
So it's 1.4 million. 1.4 million. And then we have annual maintenance cost of 40,000. So we have 40,000. So if you still remember, we need to be consistent with the units. So almost all the units here are annual worth. Okay. Annual maintenance cost 40,000. 175 per year is still A, and then 25,000 per year is annual worth. So the only cost is 1.4 million is P. So we need to change it to A. So I hope you understand this. So P is given. Okay, so P is given. You're going to look, you're going to search for A with 6% given here, and then N is 10 being given. 40,000 is already A. And I hope you know how to calculate this. You're going to check on the table, or you can use the formula, and then you're going to get some figure here, and you add with 40,000, you got 230. So now we have all the information that we need. Okay, we have B, we have D, we have C. So BC ratio, B is 175, this one. Going to minus with the this benefit, this. Okay, and then divided with C, the cost, the total cost. So here, so you got 0.65. So this 0.65 is smaller than 1. So we are not going to accept this project because the cost is higher than the benefit. We should get is greater than, equal, or greater than 1 to accept. So since here is less than 1, we are going to reject or do not build the project. So I think it's not tricky, it's not confusing, it's direct, but it's just the important thing is to extract the information, the right information, and then make sure they are in a consistent unit before we proceed with this calculation. And then we decide. Is it clear, everyone?
Clear, doctor.
Thank you.
Clear, doctor.
Okay. So you just click this, right? So usually in the classroom, if we are doing this physically, usually I'm going to give example and then I'm going to ask you to do the example, another different example for you to have the understanding. But since we are online, I'm going to show, and maybe you can, if you want to try this now, maybe we just do one and then the others I'm going to leave it for you later on. Maybe you want to try this and then you can share your answer. I already give the answer here. Can you get the same answer? Can you try? Or you don't want to try? We just go.
Okay, doctor. Okay, doctor, we are trying.
Okay. So the cost of grading and spreading gravel on a short rural road is expected to be 300,000. Please try so to see if you can extract the information. So this 300,000 should be cost. And then the road will have to be maintained at the cost of 25,000 per year. So this is again a cost. Even though the new road is not very smooth, it allows access to an area that previously could only be reached with off-road vehicles. The improved accessibility has led to a 150% increase in the property values along the road. So they are giving some information here. 150% increase in property value. And if the previous market value for property was 900,000, So this is the information for the benefit, I believe. Okay, means that by having this project, the value of the house, the property there is increased. So they ask you to calculate the BC ratio using interest rate. I 6% per year, N is 20. So we have C here, the cost 300K. So this cost is in P, right? P, present worth. And you have 25,000 per year. So this one is A. And they give market value of property 900,000. This one also we can consider as a P. So if this 2P, 1A, so you can just use PW. So this is in PW, this is in PW, so you change this 25,000 A to PW. Maybe the tricky part here is to calculate the benefit. Okay, so maybe the tricky part is to get to calculate the benefit. So we are going to use the increment value only. Okay, what is how much 150% from 900. Anyone got it? Yes, anyone got the answer right? .77. What is B? So you have 900K multiplied with 1.5, 150%. You're going to get 1350K. So basically, the tricky part is this is not the benefit yet. Okay, this is the including the the previous value, right? So you need to minus with 900. Okay, so you're going to get 450K. So the increment is 450K. So benefit is 450K. And this benefit is 25,000 per year A. So you change it to P. Okay, you change it to P. And then easily you can calculate the BC ratio, B minus D. Okay, B and D minus, then you divide it with the C, cost. So 300 plus the value here that you have changed to P. So by doing that, you're going to get 0.77. Is that okay? Anyone got the answer? Shall we move to the next? Everyone is silent, so I'm just wondering what's happening there. Shall we move? Hello, anyone? Are you still there? Anyone? Hello? Am I talking to myself?
Yes, doctor. You are still here.
Okay. Okay, doctor.
Okay.
Can get.
Can get the value, right?
Mm.
Okay. So the tricky, sometimes they're going to give some, confusing information. Sometimes they're going to give information that you need no need at all. So you need to understand which information that you should extract. Just a minute, I'm doing something. Okay. So let's move to the next slide. This is another questions. That's fine. I will just go through the lecture. So you can try this later on by yourself during the time that you have after the lecture. Then you can always compare with the answer here. So if you didn't get it, you can just shout in the group so we can discuss. Okay. So that's the first part. Okay, that's the first part for analyzing the BC analysis for single project. The same thing here. Okay, they give the information and they ask you to calculate the BC ratio. But now, when we want to select two or more mutually exclusive alternative. It means that you need to choose only one, mutually exclusive, right? You can't have both. You can't have more than one at the same time. So how we are going to do is basically we're going to compare each alternatives. Okay, so we are going to familiarize ourselves with the term of defender, challenger, and do nothing alternative. So what is defender? Defender is the currently in place alternative. Let's say you have machines. Let's say machines. Okay, so you want to replace that machine. So the existing machine is defender. It's going to defend itself, okay, from being replaced. So in place system or currently selected alternative. And we have challenger. Challenger is alternative challenging the defender. It means that the new project that we want to that we want to consider. And we always have do nothing option, which is the status quo of the system. It means that we're not going to do anything. So general approach is using incremental BC analysis of two mutually exclusive alternatives. So they have their steps. Okay, lower cost alternative is first compared to do nothing. So we are going to calculate the total cost. The total cost for each alternative given. Then by, let's say if you have three, then we are going to calculate the total cost for all three alternatives by considering the same unit. If it's AW, then everything is, we're going to compare in AW. Okay. So once you got that, you're going to choose the lower and then compare with the do nothing. If BC ratio for the lower cost alternative is less than 1, then do nothing option means like do nothing is win. Okay, so then we are going to choose do nothing and then compare them to the incremental BC ratio of the higher cost alternative. If both alternatives lose out to do nothing option, then we just select do nothing, no need to do anything unless overriding, then we need to choose the selection of the alternative that got more than one. So this is the alternative selection guidelines. Basically similar to ROR, but since you haven't yet been introduced to ROR, but it's okay, just go through. Actually, you're going to have the same procedure. Means that we have 7 steps. Okay, from 1 to 7. So determine the equivalent total cost. We check the total cost. If we have more, then equivalent means that use same unit, and then we compare. And then we rank them. Okay, we rank them, order the alternatives by increasing total cost. Means that from smaller to the bigger. And then we identify the benefit and disbenefit for each alternative, if given. If it's not given, then you just go to the step 5. What is step 5? Then you execute or do the incremental cost and benefit. But if they give it, then you just calculate the BC ratio for each alternative and eliminate all with BC ratio that less than 1. After that, we do the incremental cost and benefit for first 2 alternatives. And then we calculate the incremental BC. If it's greater than 1, higher cost alternative become defender. So we're going to choose the higher cost alternative to become defender. So we are going to repeat the steps until only one alternative remains. So the which alternative that remain at the very last assessment. So we're going to choose that. We're going to see the example. Okay. So incremental BC analysis. So this is the question. So we need to compare 2 alternatives using I. I is given 10, and then they ask you to calculate the BC ratio. So it has been given the first cost maintenance and operation cost, benefit, this benefit, and also life. And it's not equal life, right? 10 and 20. So what we should do now first, what are the first things that we need to do? The first thing, determine the equivalent total cost. So we are going to calculate the total cost, equivalent total cost. So first calculate the equivalent total cost. So which one is cost? This one, first cost and maintenance operation cost. So for these two elements, for both X and Y, okay, both X and Y, we are going to calculate the equivalent. So taking AW for both, okay. So you know 320,000. So this is P. It's given P given. You're going to search for A is 10% because it's given here 10%, and then 10N is 10 plus 45. 45 because it's in A per year. It's already A. No need to transform. So add, you got 97,080. The same thing here, 540,000 is first cost, is P. So we change it to A, 10%, and then N is 20%. Other costs related is 30, 35. Okay, here. So what are the value that we get here? The final answer is 97,080 and also 98,428. So what the rule says, order alternatives by increasing total cost. Increasing, so smaller. So this is rank number 1. This is rank number 2. What they are going to do? The first one, okay, the first one is X, right? So we are going to compare X with do nothing. Double check. Identify BD alternative. Okay, increment cost for first two alternative, and then you calculate BC. So X and do nothing. Benefit minus this benefit divided by cost. So benefit is 110 here minus 20,000 because this is the this benefit that we given, and then divided with the cost. So we already calculated here. So we got 0.93. So one is when it is less than 1, so the challenger here, okay, they lose. So we eliminate X. So we are not going to consider X. Okay, we're not going to consider X. So next is Y. And then Y is challenger, and with do nothing, 150,000 here, the benefit, minus with the this benefit, 45,000, and then divided with the cost. We already calculate the cost here, equivalent cost. So we got 1.07. So since it's greater than 1, so the challenger override, right? So we eliminate the do nothing. So do nothing so-called loss in this battle. So we are going to choose Y. So the conclusion is Y has been selected. So this is what we meant with the incremental BC analysis. So I hope you understand on this. So in this example, we are comparing two alternatives, okay? And then we always have do nothing as a status quo of the system. In the next example, we are going to choose, okay, the same scenario being given. Same scenario, okay? X and Y with all the information are the same. So here, there's no do nothing. Why? They said must select. So this is the condition. Okay, this is the condition. They say selection is required. Means that we must select X or Y. So do nothing is not an option. Okay, So if you see the solution here, must select X or Y. Do nothing is not an option. So in this case, we are not going to consider do nothing. We are going to directly compare Y to X. Why Y first? Okay, because we check here, the cost is 97,000 plus, and this is 98,000 plus. So we are going to choose the higher cost as our, for the incremental value. Okay, so we are going to calculate the difference in B, in D, and C. Okay, so the larger will minus the smaller. So for benefit, this is the benefit. So 150K minus 110, you got 40K. For this benefit, 45,000 minus 20,000. The largest minus the smallest. 45 minus 20, you got 20K. And for cost, where we get this from? Actually, we calculated previously, okay, here. Since it's the same example, we just take the information. If it's not, then we need to calculate like this. Okay, so dy minus x. Okay, y minus x. So we got 1348. So now is the operation. So y challenged by the x. What's the meaning? If it's greater than 1, we are going to choose y. If it's smaller than 1, we are going to choose x. So here, 40,000 minus 25,000 divided by 1348, we got 11.1. Right? So 11.1 means that greater than 1, we are going to eliminate x. So we select y. So y been selected. Okay. So I hope you understand this as well. Is there any confusion? Basically, when you go through more examples, it's going to be clearer for you. Okay. So we have the question here. That's fine. Maybe I'm going to just leave this. You can try later on. And we have the answer here. Okay. So you can compare. You can compare the answer. If you didn't get, then you just let me know. If you calculate, then you want to double check the answer, you can also let me know. So we go through the lecture first. Then, so we have two questions for the BC ratio. You see, select the better of two proposals to improve street safety and lighting. Use BC analysis. Okay. So the answer here, select proposal 2. So can you get this? If yes, then it's okay. So you can check, you can try this later on after the class session. Okay, and this is another example. Okay, so we have 3 examples for BC with the answer given as a reference for you. Okay, I think this is the the last concept, the last part of the lecture today. I mean, for this chapter. For BC analysis of independent projects. Okay, so actually independent project comparison does not require incremental analysis. So we are not going to, because it's an independent project. It's one project. It's independent. Nothing to to be compared things like the previous BC assessment. So we no need incremental analysis. We are going to compare each alternatives overall BC with do nothing option. So if there is no budget limit, we just accept all the alternative with BC that greater than 1. If we have more, we have 2 or 3 projects with BC ratio the greater or equal to 1, we just accept all if no budget limit. If they specify no budget limit. Okay. If budget limit specified, we have selection of the follows different procedure. We have different chapter as well, but we are not going to cover for, we are not going to cover in our syllabus for this master program here. So this is what we're going to cover, which is cost-effective analysis. So, you know, we choose projects, which projects better for us to be done, and so on, right? So, but service sector project primarily involve intangibles, not physical facilities. Okay, if it's a building, okay, your project either to select building A or building B, railway station A or railway station B. This facility or that facility, that tangible that you can see. Okay, so it's easy for us to use the VC ratio. But service sector projects sometimes it's systems, okay, intangibles. It's not physical facility like healthcare, security program, credit card services, and so on. So how we can check whether it's efficient or not, the performance of the analysis. So we are going to use cost-effective analysis, CEA, combines monetary cost, estimate with non-monetary benefit, estimate to calculate cost-effectiveness ratio, CER. So this is the formula for CER. Equivalent total cost. Okay, we're going to calculate this and then we divide it by total effectiveness measure. So basically E is total effectiveness measure and C is equivalent total cost. So we are going to identify C and E and then we are going to get the CER. So for independent projects, we have 4 steps. Okay, determine the equivalent total cost. Okay, C, total effectiveness measure, E. By having C over E, you're going to get CER. And then you're going to rank the projects by smallest to largest CER. Okay. And then determine the cumulative cost project. Cumulative cost and compare to budget limit. So in this case, you have limit. You have limit in terms of budget. And then fund all project that such is B is not exceeded. Means that we are going to accept the project until our budget is reached. Okay, let's see the example. This is the example. The effectiveness measure E is the number of graduates from adult training program. So E, okay, what is E? Effectiveness measure. So the effectiveness measure is number of graduates. Okay. For CER, shown, determine which independent program should be selected. And they give you B, 500,000. So the budget is 500,000. Okay. E is number of graduates, and they give you the CER, the performance. They give this value, and they give you program cost. If you see here, the total program cost, if you plus this, and this, is going to exceed 500,000. You only have 500,000. So which programs to be choose? That's the mission. So what they ask you to do, determine the equivalent total cost, total effectiveness measure, and then order project by smallest to largest CER. So here they already give you CER. What we need to do, smaller to largest. So which one is smaller? Which one is smaller? In this case, we already have this. Okay, no need to calculate. No need to identify C and then divide it by E in order to get CER. It's already been given here. So what we need to do? Order them smallest to largest. Which one is smallest? B. Yeah. And then D. sorry, A, and then D, and then C. So we need to rank them. Okay, B, A, C, D. So we need to rearrange the order. So it should be B, A, D, C. Okay, so you see here, this is the solution. First, rank programs according to increasing CER. So they rank now B, A, C, D as we want, based on CER. So now we know the program cost here. What are the budget that we have? 500K. So this is the cumulative cost. We know, right? Cumulative means that this 403 is means that this plus this, right? So 500, can we choose these three? BAD, the cumulative cost is 768. No, we can't. No. Because the budget is 500. So we can choose up to this. So we can choose B and also A. 403. Okay. So we select the program until budget is not exceeded. So the select program B and A. So this is the answer, but we have some additional note here. 500 minus 403K, we still have balance, right? Okay, we still have balance. Something like, is it 97K, right? Okay, if I'm right, guessing 97K. So they say you can also take D, okay, but not all, okay, maybe up to certain numbers until you can sufficiently covered with this 97K, okay, to expand the entire 500,000, accept as many additional individuals as possible from D, okay, from D here, because you still have balance 97K as per student rate. Okay. But mainly the program you can just choose B and A and some from D until the budget is out. So that's the example. Okay, that's the example of CER. For independent project, for one project, they have several programs which want to choose based on the budget. So this is for CER analysis for mutually exclusive project. Basically, we have the guidelines here. We have the procedure. If you just follow the procedure been given, then you're going to get the steps, the direction, and you're going to get the answer. Okay. So I hope you can go through this. Basically, order alternatives, smallest to largest. Okay. So you compare the E, smaller to larger, and then you calculate CER for first alternative. So the first alternative will become defender and compare to do nothing. And then you're going to calculate the incremental cost. Okay, we did this in the previous example. The incremental for C, the changes for E, and then the incremental measure, CE for challenger. And then if the challenger is lower than the defender, challenger become defender. So we want the smaller. Here we want the smaller value. Okay. If the challenger is lower than defender, so this become defender. Then we call it dominance. The challenger is dominance. So the challenger dominant become defender. And this defender is going to compare with the coming alternatives. If it's no dominance, we just take both alternatives. Okay. If dominance, okay, number 5 here. Dominant present, eliminate the defender and compare next alternative to the new defender. If dominance is not present, how can dominance not present if the CE value here, defender, is still greater than the challenger? I'm sorry, lower. So we continue the step until only one alternative remains, or only non-dominated alternative remains. So we still can apply the budget limit or other criteria to determine which of remaining non-dominant. If it's non-dominant, so we can't continue the assessment. We just leave it like that. In the real case, we are going to think another criteria, additional, what else to be considered, okay, in order to decide. Okay, just quickly check the example for the things here, okay. The effectiveness measure E is wins per person. From the cost and effectiveness value shown, determine which alternative to select. Okay, so E is win per person. So we are going to use this. Sorry. First, what you need to do, order alternative smaller to largest by E. Smallest to largest by E. Okay, using this smaller, so we need to re-rank this. Smaller, so this is smaller. This is number 2, this is number 3. So we need to re-rank them. Okay, we need to re-rank them. So B, A, C. Okay. So this is the solution. We order programs according to increasing effectiveness measure. Okay, B, A, C. So what we need to do, so I will go quickly, but the thing is we need to always refer to the steps here, the procedure here. Okay, so B, because this is the first one as based on our ranking. Okay, so they give CR 700, right? They already give it. Okay, CE, this minus this, you got this. So CE is 700. So now we are going to compare A and B. Okay. When you compare A and B, you got you need to calculate C, changes in C. Okay. This minus this, and then this minus this. You got 400. Okay, 400. So B and A, so 400. So B is, which one is dominant? We said A is dominant here. Okay, because 400 is lower than 700. So this become defender. So A become defender now. So we eliminate B. Next, C, challenging A. So when we do the incremental analysis for CE, this one is larger. So A is larger than C. So it's not dominant. So C still retained. So we still have A and C as the final answer. Okay, we are going to conclude A and C. But if they need to just choose one more, then they need to use different criteria. But for this case, A and C retain. You need to go through the example again. I know it's a bit tricky. We have give some example questions here for you to try by yourself. Okay, we give the answer here. In this answer, there is no dominant, means that there is 2 answer going to be the final. But try to do. If you have any problem later on, let me know. Okay, we give 2 questions for CER. Question 6 and question 7. And the last part is ethical consideration. I think this is more to the theory part. We know that public policy making, the development engineers, we as an engineer routinely involved in 2 areas, public policy making and public planning. Okay, so we all need to always maintain integrity and impartiality and always adhere to the code of ethics. Okay, we know about the bribery, we know about the giving the, selecting the, maybe the not good, the raw materials that not in good quality just to, reduce the price, and then you got the money. It's many unethical things. So we should not do, we should not involve ourselves in that kind of acts. Okay, so I hope we understand that. on the ethical consideration. So summary for today, we learned about the BC method to be used in the public sector. So we can use, we need to use incremental BC. It should be consistent. Okay, you can use any, but it should be consistent. If you choose PW, then you should stick with PW until to the end. If it's AW, then AW. If it's FW, then it's FW. Okay, for all of the units. For multiple mutually exclusive alternatives, we need to compare two at a time and eliminate alternatives until only one remains. So we see the cases for several things here, right? For independent alternative with no budget limit, we need to compare each against do nothing option. And select all alternative with BC 1.0 if there is no budget. And we also saw the CAA analysis for service sector project that combine cost and also non-monetary measures. And then we conclude the session with the ethical dilemmas. Okay, public projects, they got, you know, massive money, bribery things, you know, it's happening in everyday lives, but we know that's the dilemma. But as a people, as a staff that involved, so we should not consider that kind of things to be happening. So that's all from me for this chapter. So I hope you can go and revisit the lecture slide. I'm going to upload the lecture slides in the ULearn, and since your friend also need the video recording, so I'm going to also put the video recording there for you to revisit. So we are going to communicate further for the next class, and I need to give you one assignment and one project. I will finalize it later on as well. So I think that's all for the session. If you have anything to ask, then yes, please. Or I just leave you guys for times for you to do your works